Knievel, and I am an engineering tech lead at Vibration Research. In this webinar, I'm going to introduce you to the latest VibrationVIEW release for 2023 and the new features that come with that software. So we'll start by going through Vibration Research's core values. And our core focus is to make the world's most innovative sound and vibration technology tools, enabling our customers to make reliable decisions and trustworthy products. Our core values are collaboration, capable and competent, accountable and responsible, strong and driven work ethic, do the right thing, and innovation. These values govern our decision-making at a personal level and company level. Most of our values are apparent to our customers when they receive assistance from VR support. However, the concept of innovation is most evident in our products. And here is our innovation timeline, a history of VR's most significant innovations. Our first innovative feature, field data replication, differentiated VibrationVIEW from other controllers on the market in 1995. This software module allows for the one-to-one replication of field environments in a non-iterative process. The underlying algorithms allow our FDR tests to reach full level quickly, saving customers time and money. The next innovation was kurtosis in 2005. This patented technology adds kurtosis to the random waveform, allowing the peak accelerations to reflect real world, even around resonances. Other forms of kurtosis injection dampen the peaks out. And in 2010, we brought fatigue damage spectrum to the market. FDS creates random vibration tests based on field data, approaching a real world environment as closely as possible in an accelerated time frame. And the next one was IDOF, or Instant Degrees of Freedom, which improved our accuracy and reliability of short duration random tests, commonly used for complex payloads. It used an advanced and patented algorithm to deliver accurate and low variance PSD estimates. And in 2020, we released STAG, sign tracking analysis and generation. That was an add-on to our fatigue damage spectrum, which allows us to add sign tones to our test generation to better capture environments with rotational data, such as engine environments. So for our new features for VibrationVIEW 2023.2, we have 4 major ones that were in this release. An update to our test profile limits display, sign on random and random on random harmonic amplitude slopes, and a new innovation from Vibration Research, TrueClip. So for the first feature, test profile limits, we've updated our existing test profile maximum level displays to give an indication of how close those levels are to the configured shaker limits. The display boxes now will have a colored line at the bottom, giving an indication of how close to the limits and the test level that the test level is. Green for below 75%, yellow for 75 and above, and red for anything over 100% of the shaker limits. The tooltip now will show you the percentage of that percentage value and the maximum system limit that is defined. This will allow you to quickly see if a profile can run on the current shaker or help figure out what shaker you need in order to run this test. We'll now jump into the software to show you where you can find these new displays. So in our software, we can go new test and choose a test mode. We'll choose sign to start. And the edit test dialog pops up. And at the bottom here, we have these our profile limits that are from our profile. If we hover over can see that with 1 G peak in our test, we're only 2.8% of the shaker's limits. As I bump up the acceleration that the test is running at, we see these values update and we see the green bars grow. If I keep updating, then if I go too high, all of a sudden my acceleration and velocity levels are yellow, which means they're getting close to our system shaker limits. So the acceleration is at now 77% of that limit. And we also see our displacement is now red because we're running about 120% of that half-inch peak to peak that is defined in our shaker limit. And if I go into the other test modes, these boxes also appear here. So if I key in a random breakpoint table, these values will update and show the test running at full level. And for this, we're only 4% of our shaker limit. Go into shock. And again, at the bottom, they are right here for 2G, and I can, as I bump this up, they will update as well. And finally, field data replication. I will need to add a file for playback in order for the values to appear. I'll just choose this one. And we can quickly see the levels that this VFW needs to run and that they are in our shaker limits. So we could be good to run this test. Our next feature is a feature for both sign on random and random on random when you are creating a test profile. This will make it easier to create tests from specifications like mil standard 810H that require harmonic tones that have amplitudes that are defined based on the slope of dB per octave or dB per decade. The mil standard 810H defines amplitudes, sine tone amplitudes at 4 frequencies that are harmonics of the first frequency and require that the amplitude of each of those tones follows a slope. And I will jump into the software to show how to create a test using that new slope feature. So we'll go new test, sign on random, and we already have a table defined. I will leave that at the default and go into the sign on random tab. Now I have one tone to start at 150 Hertz. I will change it to 100. And I can insert another tone. And using the drop down, select harmonic. So I get an option for the multiple of frequency that I want to run from the first tone. So leave that at 2. And I have an amplitude value. This can either be a multiple of the amplitude, which was available in previous versions, but now there is a drop down where we can add dB per octave or dB per decade. So we can select dB per octave and key in -3 for that slope. Now with 2 sine tones, I can then keep inserting to get the 4 tones, and they are automatically incremented in frequency but stay on that dB per octave line. If I select the acceleration PSD, we can now see the random background demand along with those tones on that dB per octave slope. So this makes inputting these tests much more convenient and easy for the user. Likewise, if I turn sign on random mode off and go on to random on random, I can turn that on and insert another band. From the drop-down again, select multiple of, and I'm given the same options of the multiple of the frequency I want and the multiple of the amplitude, which can then be changed to dB per octave again with a -3 slope, and I can continue to insert these bands. So that is the 2 sign on random and random on random features we've added for this release. And for the final feature, this is a new innovation that Vibration Research developed for a new method of clipping called TrueClip. It's available in the random test mode, and it utilizes closed loop control to reduce high sigma peaks on the shaker table. And we can minimize the chance of exceeding our maximum limits in acceleration, velocity, or displacement. So a bit of background of why this might be necessary. For a random noise test, the amplitude values have a certain probability of occurring at a high sigma level. The higher sigma peaks will have a lower probability of occurring, but they can still be likely over a long duration of test, up to somewhere like 6 times the RMS value. That might only appear much later when running a test. Previously, what was available was voltage clipping, which applied to the output, but that didn't quite translate into acceleration, velocity, or displacement clipping. You wouldn't see the clip appear on the control accel that you are listening to. So TrueClip affects the control, acceleration, velocity, and displacement and limits the peak sigma values. And we can apply it when running a test to protect the shaker system or the product when running these long random tests where you're likely to see some high sigma values. And this is just a quick representation of the differences between voltage clipping and acceleration clipping. So on the left column, I have all voltage traces, and on the right, I have all my acceleration data. The top black line is with no clipping, so you can clearly see peaks in both voltage and acceleration exceeding the red line we defined. When we turn voltage clipping on, we see the voltage, this purple trace here on the left, get reduced to that 3 sigma value that we defined. On the acceleration data, we still see those peaks even though voltage clipping was applied. But now with TrueClip, we can turn on acceleration clipping. And while we don't see the clipping in the voltage that is coming out of the controller, we can clearly see in the acceleration data that these peaks have been shrunk and reduced. And I can now go into the software to show you how to set up TrueClip to run on a random test. You can go New Test, Random, go to Advanced to bring up all of the options in parameters on the Parameters tab. Where sigma clipping is, we now have 3 new options: TrueClip acceleration, velocity, and displacement. If I select acceleration, and hover over the clip above box, we can see that this test requires 1.8 G of could be likely seen with this 6 sigma value. I can lower this to reduce my peaks to 4 sigma, and this combo box will update now to 1.2. And so when I run this test, the peaks above 4 sigma are going to be reduced to that level. Some reasons you might want to do this are, like I said, of wanting to keep these high peaks from tripping out your shaker when you're running close to these shaker limits, or when there is a sensitive product that can be affected by these high peaks that you wouldn't typically expect or typically want to contribute to the overall test. And likewise, the displacement clipping can be done when you're running near the displacement limits of the shaker. And that can be turned on just by selecting the displacement method. And you can see in the tooltip that we also show the inches peak to peak that you expect with this 4 sigma value enforced. And you see our current system limit of the 1/2 inch peak to peak of our shaker that we've configured for here. And also, voltage clipping can be done, and one reason you might want to do that when running a servo hydraulic shaker is to limit and keep it under the maximum flow to help prevent cavitation. So those are the new features for VibrationVIEW 2023.2. If you have any questions, I can answer them now through the questions dialog on GoToMeeting. Looks like there's one for shaker limits. What are the risks of under testing the product with TrueClip? So it's a good question. If we go back to dialog, just so I have something to point to. Yes, if you turn on TrueClip and you drastically reduce the sigma, like below 3 or even below 4, this can adversely affect what you're expected to run. Anything below 3 will start having an effect on your RMS, just like regular clipping will, because you can't reach a level in order to achieve that RMS value that you're trying to run your test at. You're really just looking for some of these like 4 to 6 sigma where they are unexpected or infrequent enough that you don't have that as much of a risk in under testing. And if we key in something like 2 and try to edit the test, we will pop up a warning that this will distort your test. We've added this for all the clipping methods, just so it's clear that under 3 sigma, you're not testing what you think you should be. Let's see, other question about for the shaker limits, what about total payload? So we don't have, if I think I understand your question, of what your moving mass will be and if you exceed some set value here based on your shaker set limits. I don't think we have any way to show that when you're creating a test, but we have these mass values that you can key in here that will affect what your shaker limits are. All right, I think that'll complete this webinar. Thank you all for attending, and we hope you use and like the new version of VibrationVIEW. Thank you.